Welcome, Pre-Calc. Let's take a look at Chapter 5, Section 3, continuing on, solving trig equations. Today we're going to take a look, first of all, at equations of quadratic type. If you remember back to Algebra 2, quadratic means you have an x squared. So ax squared plus bx plus c equals 0 is your standard form of a quadratic. What would you do if you have an equation that is quadratic and trigonometric at the same time? We have a squared, not squared, and our constant term. We're supposed to solve it from 0 to 2 pi, so just those solutions. Well, the first thing that we would do would be we'd factor. If you think of this as 2x squared minus x minus 1, you could probably factor it. We're going to do the same thing. Just because it has signs in there, don't let that scare you off. So, how do you get a 2 sine squared? Well, you have to have a 2 sine here of x and a sine of x here. How do you multiply and get negative 1? Well, the only factors of 1 are 1 and 1, but because it's negative, one of these will have to be positive, one of them will be negative. I don't know if it's positive 1, negative 1, or negative 1, positive 1. But what I do know is that my middle term has to turn out to be negative 1. So, where do you want the positive? Where do you want the negative? You're checking your outer and your inner terms when you're done to make sure that they add up to negative 1 sine x. Let's try positive here, negative here. If that doesn't work, then we'll switch them and we should be good to go. If it can be factored, well, we're good. 1 times sine of x would be 1 sine of x. 2 sine x times negative 1 would be negative 2 sine x. If I add those together, do I get negative 1 sine x? You sure do. So I'm going to say that we factored it correctly. What we have now is one factor times another factor that's equal to 0. And if you think back to solving a quadratic, one of the techniques is factoring. You then take each factor and you set it equal to 0. So take my first factor, set it equal to 0, I'll solve. Take my second factor, set it equal to 0, and solve. My first equation comes out to be sine of x equals negative 1/2. Second equation, add 1 to each side. Sine of x equals 1. So we're supposed to think from 0 to 2 pi, what angle could I put in here so that when I take the sine of that angle, I get 1, or I get negative 1/2. Let's start with the 1. Thinking of my unit circle. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Where is sine equal to 1? Well, right up here. Cosine and sine. What angle is that? That's 90 degrees. Okay, but in radians, because it says 0 to 2 pi, it doesn't say 0 to 360 degrees. So 90 degrees would be pi over 2. My first answer, x is pi over 2. How about you think about your next answer then? Where is sine equal to negative 1/2? Well, if we think about our unit circle again, we've got our 45, we got our 60, we got our 30, and we have 1, 2, 3, 1, 2, 3. Everything's over 2, and we take our square roots. So where is sine going to be equal to positive 1/2? Well, let's see. Cosine's first, sine is second. So right here, 30 degrees. That gets you positive 1/2, but we want negative 1/2. So where is sine negative? Think back, all your trig functions are positive here. Only cosine's positive, only tangent's positive, only sine is positive. Since we want negative, I do not want this quadrant, I do not want this quadrant. I want both of these. Cosine's positive, but sine's negative. Tangent's positive, but sine is negative. So I'll have two answers. I need to think about what my angles are down here in quadrant 4 and quadrant 3. That would be equal to negative 1/2 when I take that angle. Sine of what angle? Well, 30 degrees. 30 degrees past 180 would put you at 210. 30 degrees from 360 would put you at 330 degrees. If you need to, multiply by pi, put it over 180, and reduce. Multiply by pi, put it over 180, and reduce. (21 pi over 18 reduces. They're both divisible by 3. Divide by 3, divide by 3. So one answer is 7 pi over 6. 330 pi over 180. Cross off a 0. 33 pi over 18. They're both divisible by 3. Divide by 3, divide by 3. Looks like my second answer is 11 pi over 6. I have 3 answers. There they are. Good stuff, huh? All right. I'm having fun. I hope you are. I'm having more fun because now it's your turn to try. Pause your video. Come on back when you are ready. Welcome back. If it helps you, think of this as 2x squared minus 5x plus 2 as you try to factor. How do I get a 2x squared? Well, I would need a 2x and an x. How do I get a 2 cosine squared? Well, I would need a 2 cosine of x and a cosine of x. Your last number is positive 2, but your middle term is negative, so you need 2 negatives. Negative times a negative is a positive. Factors of 2. We could have 1 and 2, we could have 2 and 1. And yes, order matters because this is a 2 cosine x, this is only a 1 cosine x. Where do you want the 1? Where do you want the 2? Where do you want the 2? Where do you want the 1? When you're done, you need to have -5 by checking your outer and your inner terms. 1 here, 2 here. This gives you -1 cosine of x. 2 cosine x times -2 would be -4 cosine of x. You add them together, you get -5 cosine x. Hopefully next you would take each factor, set it equal to 0 and solve. Take each factor, set it equal to 0 and solve. Let's start with this one. Nice easy whole number. Where is cosine equal to 2? Yeah, it's not. Doesn't mean there's no solution. We still have this equation over here. We need to think, where is cosine equal to 1/2? Okay, so we got our 45, our 30, and our 60. We got 1, 2, 3, 1, 2, 3. The first set of numbers are your cosine. Where's it equal to 1/2? Right here. What angle is that? 60 degrees. But in radians, because we're going 0 to 2 pi, 60 degrees would be pi over 3. Is there anywhere else where cosine is going to be equal to 1/2 from 0 to 2 pi? Oh, let's see. AC. Here we are in this quadrant. 60 degrees from 360 would put me at 300 degrees. If you need to, put 300 pi over 180. Cross off your zeros and reduce your 30 pi over 18. What are they both divisible by? Well, they're even. Yes, you could cut them in half, but we can do better. 5 times 6, 3 times 6. Sounds to me like they're both divisible by 6. So let's divide by 6, divide by 6. Those are our two answers. See? Told you we're having fun. Oh, wow. Half off haircuts. Hey. So he goes back in. What? This is going to take forever. Get it? Because he got half, then half of half is a fourth. Half of that would be an eighth, a 16th, a 32nd, a 64th. This is going to take forever. You betcha it will. Half of half of half of half of half of half of. Okay, I get it. Yeah, homework helpline. I need to have you explain the quadratic equation in roughly the amount of the time it takes to get a cup of coffee. Poor kid's in there trying to do her math homework. Dad doesn't know how to do it. How many of you are beyond the point where your parents can help you with your math? Yeah, I got to that point too. It's very common. It's okay. Just keep that in mind when you have your kids one day. Somebody's going to need to help them with math. It's going to be you. Algebraically find all solutions. Oh my goodness, it's not just from 0 to 2 pi. It's everything. Hey, that sounds like fun to me. Well, we can't factor this as it's set up because cotangent is not the same thing as cosecant. I believe I'm missing a square here. Let me add that square in. Okay, there we go. I feel better. Cotangent squared, cosecant squared minus 7. Well, we have some Pythagorean identities. One of them is sine squared of x plus cosine squared of x equals 1. One of them is 1 plus tangent squared of x equals secant squared of x. Yeah, still don't see the ones I'm looking for. So what's our third one? And remember, we get it by taking the original and dividing by sine squared everywhere or dividing by cosine squared everywhere. If you don't know it, why don't you just go ahead and divide the original by sine squared, sine squared, sine squared. See what you come up with. That's what I'm going to do. If that doesn't work, I'll go back and divide by cosine squared. Would I be that evil and do that to you? No, not this time. Sine squared divided by sine squared would give me 1. Cosine over sine. Well, I know sine over cosine is tangent, so cosine over sine would be cotangent. And then 1 over sine would be cosecant. There we go, cosecant. How about we substitute this right here in place of this right here. So, cotangent squared of x plus substituting in 1 plus cotangent squared of x minus 7 equals 0. Like terms, cotangent squared plus cotangent squared would be 2 cotangent squared of x. 1 minus 7 would be minus 6. What would you like to do next? Well, it's not exactly like the last one because there's no middle term. We could divide everything by 2 because that's even, and that's divisible by 2. So let's do that. Divide by 2, we get cotangent squared of x. Divide by 2, we get 3. Divide by 2, we get 0. Ideas? Add 3 to both sides. Got it. Which you didn't have to divide by 2. I mean, you could have added 6 and then divided by 2. You'll get to the same place. It's okay. Cotangent squared of x equals 3. Cotangent of x would equal positive or negative square root of 3. So we need to do a little thinking. Where is cotangent equal to radical 3? Oh, those are always the tough ones, right? 1, 2, 3, 1, 2, 3. Everything's over 2, over 2, over 2, over 2. Square root, square root, square root over 2, square root over 2. Oh my goodness. Well, it's not 45 because that, when you take cotangent, cotangent is cosine divided by sine. And if they're both radical 2 over 2's, you divide them out, you get 1. So it's not the 45. It's either 30 or 60. One or the other. One or the other. Which one do you want to start with? If we pick the wrong one, we know we just picked the other one, and it'll be fine. Okay, let's just start with 30 degrees. Okay, so 30 degrees. Cosine is radical 3 over 2. Divided by sine is 1/2. Keep, flip, change to multiply. Look at that, the 2's cancel out. I get radical 3. Good choice. We got so lucky. So x equals 30 degrees. Is there anywhere else that you're going to get that 30 degrees for radical 3? Well, both of the signs have to be the same to get positive radical 3. Is there anywhere else where both of the signs are going to be the same? 2 positives or 2 negatives maybe? Like maybe right here? When tangent is positive, so is cotangent. Because both of these will be negative. 2 negatives make a positive. So, what is 30 degrees past 180? It's 210. If you need to, take your 210 pi over 180, cross off a 0, and see what divides into both of them. 3 times 7, 3 times 6, sounds to me like they both divide by 3. So, divide by 3, 7 pi over 6. That takes care of the positive radical 3's. Where is cotangent going to be negative? Well, that would be when one is positive, one's negative. And that happens here and here. 30 degrees less than 180 would be 150 degrees. 30 degrees less than 360 would be 330. 150 pi over 180. Cross off a 0. 15 pi over 18. What divides into both of them? What divides into both of them? Yeah, 3. 3 times 5, 3 times 6. 5 pi over 6 gets me my 150. Try to do the same thing with the 330. 330 pi divided by 180, cross off a 0 from each of them, 33 over 18. What divides into both of them? 3 times 11, 3 times 6. They both divide by that. So there's our answers from 0 to 2 pi, but that's not really what it asked. It said find all solutions. So it looks to me like all the 30-degree reference angles. If we start at 30 degrees, the red one, the other one is 180 degrees apart. If we start at the 150, the other one is 180 degrees apart. So what we really need is to start at each of those and add any value of pi. Start at 30, add 180, add, gets you here. Add 180, gets you here. Add 180, gets you here. Add 180, gets you here. If we start at 150, or 5 pi over 6, I add 180, I get to here. 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 So any value of pi. These would be our general solutions that cover every angle that solves our problem. How about you and your group take about 20 minutes practicing equations of quadratic type? They're not easy. Try your best. Hit pause. Come on back when you're ready. The last thing we're going to look at today are functions of multiple angles. So you have sine or cosine of some multiple times an angle. And when I say that, I mean like 2x or 3x or 4x or 5x, that kind of thing. Something like such. What we'll do is we will solve for KU. Then when we're done, we'll simply divide our answer by K. It'll be okay. So, don't worry about it being a 3x right now. Let's just pretend that it's 2 cosine of x minus 1. What would you do to solve? Yes, you would. You would add 1 to each side, okay? Divide by 2, like how you're thinking. Good, good, good. And now we think, what angle of cosine would equal a half? We'll start with just 0 to 2 pi, then we'll generalize it. Think of your unit circle. Where is cosine a half? Right? 1, 2, 3, 1, 2, 3. Cosine's the first one, right here at 60 degrees. So 3x equals 60 degrees, pi over 6. Not just x, but 3x. What would you do next? Well, do you have any other angles that cosine is going to equal 1/2? That would be AC. Cosine's also equal to 1/2 here. 60 degrees from 360 would give me 300 degrees. 300 pi over 180. Cross off zeros. Reduce 30 over 18. What goes into both of them? 5 times 6, 3 times 6. I think I wrote pi over 6, and I meant to write pi over 3. I wanted 60 degrees, not 30 degrees. Way to go, Mr. Brown. Hey, what do you want? I'm 82. I finally made a mistake, okay? So that's 3x. Let's generalize them. This is 0 to 2 pi. Our general solutions, pi over 3. So we're sitting here at 60 degrees. There isn't one on the opposite side, 180 degrees apart. I have to go a full circle to get back here. So that would be 2 pi n. 300 degrees. I can't just go on the opposite side, 180 degrees. I got to go a full circle to get to the other one. 2 pi n. But that's still equal to 3x. So, how do you find just x? Well, you divide by 3, duh. We'll divide that by 3, divide that by 3, divide that by 3, divide that by 3. So, x will equal pi over 9 plus 2 pi n over 3 and 5 pi over 9 plus 2 pi n over 3. Those would be our general solutions for any angle, not just from 0 to 2 pi. Have some fun with that one. That sounds amazing. Miss you guys. See you next time. Bye.